Hello everyone, welcome to the channel. So in this video, I'm going to show you how to calculate the lake area using Landsat 8 imagery in Google Earth Engine. So now let's get started. So first we need to define our region of interest. So for that I defined a variable called geometry, with the geometry representing the latitude and longitude of this study area. So now to create a region of interest, so navigate to this option called draw a rectangle. So once you did that, so I'm going to draw a rectangle over the specific lake. So I'm going to calculate the area for this specific lake called Pulal Lake, which is located in Chennai. So you're going to draw a rectangle or a polygon over this specific lake here. So once you did that, you can navigate the section here and click this option called Edit Layer Properties. So here you can change the name of this particular polygon or the study area. You can change the color as well as you can delete this. So now click OK. So once you created your region of interest, next we're gonna navigate. So map.add layer, we're gonna click this option, make this option called map.add layer geometry. So we're gonna add this layer into Earth Engine. Next, to center this layer, we define map.center object geometry with a specific zoom level of 12. So geometry represents our study area. So next, we have to set our time period for analysis. So we defined a variable called time start equals to 2016 and the time end of 2022. So basically this specifies the time range for filtering the Landsat imagery from 2016 to 2022. Next, we're going to filter and process our Landsat 8 imagery. So for that we defined a variable called Landsat equals to w.image collection Landsat lc8 collection to tire, and this section filters our Landsat 8 image collection. And to include the images from 2016 to 2022, we define dot filter date, time start and time end. And to include the image with the cloud contamination less than 10%, we define dot filter dot filter dot less than cloud cover, that is we specify the number here 10. And next we're gonna include the images from June to September. So for that we define dot filter dot filter dot calendar range. I have mentioned the month of June to September using this calendar range 6 and 9, and this is the month. And to next we dot filter bound with our study area. For that we define filter bound geometry. So geometry here represents our study area. So dot map function img. So we defined a variable called bands equals to img dot select sr. So sr here represents the surface reflectance. So next we dot multiply 2.75 into 10 power minus 5 and add 0 minus 0.2. So it is a scaling factor. It is used in the Landsat 8 imagery. So this scaling factor is likely used to convert the integer value stored in the image bands to actual surface reflectance value. So the Landsat 8 surface reflectance product often uses scaling factor to store the data efficiently, and this constant minus 0.2 to be scaled surface reflectance value. This adjustment might be necessary to further correct or normalize our reflectance value. So next we defined a variable called NDWI, that is Normalized Difference Water Index equals to bands dot normalized difference SR band 3 and SR band 5 dot rename. So this specific code will perform the band normalized difference, that is to normalized difference water index. So let me show you the formula for the normalized difference water index for Landsat 8 imagery, that is NDWI equals to green minus NAR divided by green plus NAR, which gives us the NDWI. So that is band 3 minus band 5 divided by band 3 plus band 5. So this is Landsat 8 imagery, and this is the code we are using in this video here. So bands, the SR3 represents the green band, and similarly SR5 which represents the near infrared band. So let me get back to my Earth Engine here, and for each image it computes the NDWI using band 3 and band 5, and NDWI is highlighted to it's used to highlight the water bodies in our study area. So next we have defined dot copy properties img image dot property names, and last we define dot median. So it computes the median of NDWI over the filtered image from the time range from 2016 to 2022. So next, to add this layer in our Earth Engine, we define this section. So map.add layer Landsat.clip geometry default visualization NDWI. So this set of code will add our NDWI, the median NDWI clipped using our study area boundary. That is, we are use this variable geometry. So next we define map.add layer Landsat.clip geometry dot greater than 0. With the default visualization parameter, I'll output the layer name as NDWI threshold. So the threshold of NDWI, the pixel with NDWI is greater than 0, is clipped to our this particular polygon, that is our region of interest. So basically it adds our layer with NDWI greater than 0, which represents the water bodies. So next, to create and add a masked NDWI layer. So for that we defined a variable called threshold equals to the Landsat dot greater than 0.1. So this section creates a binary mask for NDWI value greater than 0.1. And next we defined a variable called mask equals to threshold dot update mask threshold. Hence it applies the mask to the highlighted areas with a significant water presence, which is indicated in this variable here. So to add this layer into our Earth Engine, we define map.add layer mask with the default visualization parameter and output the layer name as NDWI mask. So now to calculate and add the pixel area layer, we define this variable called pixel area equals to mask dot multiply w dot image dot pixel area, and we're going to divide it by 1:10 power 6 to convert to this unit into square kilometers. So this section calculates an area of each pixel in square kilometers for the masked layer and adds a layer to our Earth Engine. So next, to add our the pixel area into our Earth Engine, we define map.add layer pixel area dot clip geometry represents our study area default visualization parameter and output the layer name as NDWI pixel area. So now to calculate the total area, the total water area, we defined a variable called lake area equals to pixel area dot reduce from region reducer w dot reducer dot sum geometry represents our study area and scaling to factor of 100 and dot value dot get 0. So this entire section calculates the total water area within the ROI, that is our this particular study area, by summing up the pixel areas in the masked NDWI layer. So the total water area is printed in our console section here. So now we're gonna run this code. Navigate to this option called run and run script. So now here the total area for this particular lake, that is Puller Lake, it is given in the console section here. That is 8.57 square kilometers for this entire lake here. Let me turn this off. So the area of this entire Puller Lake is about 8.57 square kilometers. So now let us visualize this first layer. So this is our study area. So the second layer is that is NDWI, that is Normalized Difference Water Index. So now here you can able to visualize it. So we can add a visualization parameter and make it a colorful image here, that is NDWI. So for now we can able to identify the whitish areas here indicates the lake areas. We have done using our NDWI, and once we've applied our NDWI threshold, so to calculate only the water areas, so we can able to see here. So all the water areas in this specific study regions are indicated in this specific color, that is white color. And next we have masked it. So specifically we have taken only the water pixels, and left we have masked all other pixels here. Only the water pixels are visible here. And last we're gonna visualize our NDWI pixel area. So we have managed to find the lake area, and also we have done from only from June to September. So the lake area changes from June to September from 2016 to 2022. So this is the lake area changes here from 2016 to 2022. only in the months of June to September. This is the lake extent. Let me turn on the satellite image here. So you can able to see, let me turn on this particular masked one. So this is the actual extent of this polar lake. Now this is the extent during June to September, which is indicated in the black here. The black pixelated images here, you can able to see that. In this way you can able to calculate the lake area using this specific code here, and the link for this code will be given in the description. So in this video I have shown you how to calculate a lake area using Landsat 8 imagery in Google Earth Engine. So thanks for watching, and please subscribe to our channel and give us a like.